Before we go any further with our code here for our RGB stuff, we want to go ahead and define some variables in our function. So we're going to go ahead and get rid of our header here, and we are going to make some significant modifications now. So at the top, we are going to decide what 10, 11, and 12 mean only once, so that we don't have to keep remembering that 10 means red, 11 means green, things like that. In C-based languages, like what Arduino uses, we are going to write the pound sign and then define, hashtag, if you must, define, and then we are going to type in a name of something, and I'm going to say red pin with an underscore. We don't use spaces when we're creating variables like this, so an underscore would be a way of essentially creating a space. And I like to use all caps when I'm doing any kind of constant. This is what we're doing, where it's called defining a constant. So every time that we see the words red pin with an underscore, all in caps, we're going to replace it with the number 10. And by we, I mean your computer will for you. So here I have a 10. I'm going to put red pin, because that's going to be more meaningful to me. Here I have a 10. I'm going to put red pin. And before this program runs, before it is sent to the microcontroller, the Arduino software is going to look at everywhere it says red pin and automatically replace it with a 10. Now, I called it a variable initially. That was a little bit of a slip up. It is a constant, meaning that every time you see red pin, it will be 10. You cannot make it 11 sometimes or 12 later. It is always going to be 10. And in our case, we always want it to be 10 because that's the port it's plugged into. It will not change. So, unless someone rewires it, but they won't do that. I'm going to copy and paste this a couple times because I'm a little bit lazy, and we're going to change the next one to green and the last one to blue. And we're going to say green is pin 11 because that's where we put it, and blue is pin 12. So we have red pin, green pin, blue pin, all with those underscores between them, 11, 10, 11, 12. And I'm going to replace all of these numbers here with these nice names. That way, if we ever use it anywhere in our code, we don't have to remember what those numbers mean. So we're trying to make this as human readable as possible. Just to prove that this actually does work, let's go ahead and upload this and just make sure that nothing crazy is going on. Nothing should change in our circuit from the way we had it before. And in fact, it is doing exactly what it did before. It's dimly lit because it is only on 1/11 of the time, just blinking very, very fast. So now let's go ahead and keep getting into changing our code. What we want to do is be able to mix colors. Colors typically are defined with numbers on a computer. Usually a number between 0 and 255 represents a color. So for example, 0 means totally off, 255 means the full power of that color, and some number in between represents the fraction out of 256. Because remember, if you start counting at 0, that's a digit. So 0 to 255 is 256 different numbers. So I'm going to start actually going up to my setup, and I'm going to create some new lines here, and I'm going to create a variable called red power. So, and I'm going to put an int because it is an integer number. Red underscore power is the way I'm going to choose to name my variables. There's lots of conventions for this. If you don't like mine, that's fine. Int red power equals, let's go ahead and make it full power, 255. And I'm going to leave myself a little comment on the side. So I'm going to put 2 forward slashes and then 0 to 255. Everything I type after those 2 forward slashes is not code. I could put hello mom right there and it wouldn't matter. That's not useful though. I'm going to copy and paste what I did here a few times so that I can probably do what you're going to suspect, green power and blue power. And just to test it out, I'm going to make blue power like 100, and I'm going to make green power 0, just to make sure that this is in fact working. So if my code works in a little bit, red's going to be all the way on because I maxed it out. Green is going to be all the way off because I put it at 0, and blue is going to be somewhere about halfway, a little less. These numbers mean nothing to the computer right now. They are known to be integers, meaning whole numbers, and that's about it. They don't mean it should be on or off a certain amount of time. We have to write the logic behind that. So I'm going to go up here in our loop function and tab over so that I am kind of spaced in line with the I of void up there. And I'm going to write a loop. And the way that loops work is they repeat things over and over and over and over again. Now you might say, you have a loop function. You're right. But what if I want to loop inside my loop? Then I need to write something like this. Loops start with the word for, typically. There are multiple ways to do it, but for loops are one good way to do it. For, and you need to define three things for a for loop. What is the variable that's going to count? What is it, and where it starts? When does it stop? And what do you do to that counter each time? So I'm going to say int I equals 0. Now, you could choose to use any variable. I use the letter I because it's kind of the typical one used. So you'll see that a lot in example code. So int I equals 0. And then I is less than 256. And then I plus plus. So let's take apart what that means real quick. Int I equals 0. I'm going to use I as my counter, and I'm going to start it at the number 0. So the first time I count is 0. I am going to keep doing this until I is no longer less than 256. Now, that means on the 255th iteration, that is going to be the last one. But because it started at 0, there were a total of 256. So it will run 0 all the way through 255 and then stop. It will not actually run 256 because 256 is not less than 256. It is less than or equal to. Finally, I plus plus, which means that we count up 1 each time. You could say I plus equals 2, or there are other ways, I equals I plus 2, things like that. This is shorthand for saying I equals I plus 1. So each time I want I to go up by 1. The shorthand way of doing that, I plus plus. That's where the name C++ as a language comes in, because it's the next increment of the language C is the idea. Put a curly brace that's open at the end, and when I hit enter, the Arduino software is very nice to me. It puts a closed curly brace down here for me, and it tabs me in so I'm indented and I know where I'm working. Inside this loop, I probably want to do something, but I realize that the logic that I'm going for here is I want to turn all the LEDs on right away. So I'm going to say digital write high for all three of these. I'm going to copy and paste all of this, cut and paste it actually, up here so that all three are turned on. Red pin's on, green pin's on, blue pin's on. High means on. Then inside my code, I'm going to ask a question. If, and I'm going to look at my red power here, or let's use blue power for the first one just actually because it has an interesting value, 100. If that blue power is smaller than my counter, so at step 0, blue is bigger than the counter, nothing changes, so it's going to skip this line. But when it gets to 101, then blue power is going to be smaller than I. When that happens, I want it to turn off blue. So I'm going to then copy and paste this line here about blue going high, and I'm going to say make it low. So if the blue power number is less than I, make it low. And I'm going to use this logic for all three colors. And I'm going to actually do it in the original order, the red, green, and blue. And thus, red pin, green pin, and blue pin. And so what I've done is I've turned at the start of my loop, I've turned all of them on. All lights are turned on. And then this is going to start counting at 0. It's going to say, red power, are you less than 0? Well, it looks like nobody's going to be less than 0. 0 is the smallest it gets. So I might actually want to say less than or equal to. That would probably be more appropriate. On the first loop, it looks like green is 0. So is green power less than or equal to 0? It is now. It is. It's the only one that's less than or equal to 0. Then green pin's going to get turned off. And now when we get to the end of here, it's going to pop back up to here. It's going to stay inside of these three lines and repeat it 256 times from 0 to 255. So that goes on for a while. Nothing happens with the red and blue. But at some point we get to 100. And when I is 100, blue power 100 is less than or equal to it. And so it's going to turn the blue off. Red's going to stay unaffected all the way through. In fact, only on the last loop would red be potentially affected here. 255 less than or equal to 255. And so the point is of what we just did here is we figured out how to control the relative amount of time that each is on. I'm going to add a delay here, delay of 1 millisecond. And we're going to see how this code behaves. I'm going to actually get rid of this code I have down here because I no longer am going to need that. And we're going to see how this works. And if it works. It looks like I made a mistake. Red power was not declared in the scope. What that means is that red power is up here. It is not, the code does not know what is going on. It doesn't know what red power is. I didn't define it globally in my program. There are ways to do that, but I'm going to be doing the quick one here, which is just to cut and paste that code from above and paste it down here. And I'm going to tab this over so it looks nice. So I took my int red power, green power, blue power, and all those numbers and cut and paste them into the loop function. So they are redefined each time. There are other ways to do this that are cleaner, but for now, this is going to work. I'm going to try uploading it now, and it looks like it is verified my code as working. And we're going to see how that behaves. So if we look at this, something interesting has happened. The red is on all the time, the green is off all the time, and the blue is flickering on, off, on, off. If we look at our code, that's exactly what we expected because we said the red pin should only turn off when this number gets below or equal to this number right here, this 255, which happens for maybe 1/256th of a second, or less than that actually because of the length of the delay. It only happens for 1 millisecond that would be turned off, and that's even just poor programming on my part. We should really never have it off. So the point is that this is working as expected. The problem is this delay is too long because what I want is it to be so fast that we can't see that flickering. To achieve that, we need a delay that's even smaller, and so we're going to use another built-in function called delay microseconds. And we are going to give that a number of only 10 microseconds. This is 10 millionths of a second, or 100,000ths of a second per loop. Now remember, a loop, we have to multiply this time by 256 to make one complete cycle, one complete blink cycle. So it actually is quite a bit longer than 100,000ths of a second. Let's flip our camera down and see what we're getting now. Now we're getting full on red and the blue is on half power. It's a little hard to tell because our blue ones seem to be a little bit brighter than the others before, and our green is totally off. If we continue to play with this idea and we were to switch these, we would see what happens when we change the relative values of these two and upload this. So if we watch our LEDs, now you can see the red is quite a bit dimmer and the blue is quite a bit brighter. We cut the red's power down to less than half and the blue more than double. And the green is still turned off. The idea here is that by mixing the red, green, and blue color, you can figure out what values those are using different websites. And using those numbers, you can create any color. For example, if you Google Rgb Color Picker, you have this handy tool that pops up, thank you Google, where you can pick relatively what you want and then kind of zoom in on the exact one you want here, and it gives you numbers, and then it gives you it in hex codes. These are actually numbers, they're just written in hexadecimal. And then it gives you the RGB numbers. 237, that's how much red. 218, that's how much green, and 14 is how much blue. So 237, 218, and 14. If you were to pop those numbers into your code that you've been writing here for red, green, and blue respectively, you would, if you held those LEDs really close to each other and stood a little ways away where your eye could blend them, you would create that color yellow. And you can do that with all kinds of colors. Note if your LEDs are not equally powered, of course these numbers are not going to work the way they're supposed to, but if your LEDs are set up correctly, then it will be pretty awesome. In the next video, we're going to take a look at how to take this little thing here and parse it out into its own little function that we can call as needed so that we can repeat it and do cool things like blink different colors in succession.